All right, now this one, people missed the clue that made this one very easy. So you're given three vectors, u, v, and w. Let me do the painting hand. You have u, v, and w, and A is 3 by 3 matrix whose columns are u, v, w. Matrix A is non-singular. People miss this. Non-singular. Okay. In fact, people went ahead and row reduced and discovered it's non-singular. But that actually gives you the key to the problem. Determine whether or not W is in the span of U and V. Okay. All right, so what does non-singular mean? Non-singular implies that the homogeneous equation, let's say x1 times u plus x2 times v plus x3 times w equals 0, has a unique solution. And the unique solution is x1 plus x2, x1, x2, and x3 are all equal to 0. x1 equals x2 equals x3 equals 0. Okay, what does that mean? There is no non-trivial linear dependence relation between u1, just say joining u1, u, v, and w. Okay. Now, in particular, that means we can't find x1u plus x2v minus w is equal to 0, which means that x1u plus x2v equals w has no solution. Okay, so that means that w is not in the span of u and v. You could have also done this more directly by thinking of u, v, and w. Thinking of this matrix A not as a coefficient matrix, but as a augmented matrix where w is the augmenting column, and you would directly get that w cannot be expressed as the linear combination of u and v, because when you row reduce, the last column is a pivot column. So that basically finishes the problem. W is not in the span of u and v.